Hello everyone. In this week, we have been looking into seismic design of masonry buildings. So far, we have looked into material specifications, geometrical detailing and permissible stresses in masonry walls. Today, in this class, we will discuss about some of the ductile detailing provisions from IS 4326 that apply to masonry buildings for obtaining good seismic resistance. For good seismic resistance, we need to have certain restrictions on geometry as well as ductile detailing of these masonry walls. In case of unreinforced masonry wall, the maximum height of a masonry building can be 15 meters or 4 stories in general. This is measured from mean ground level to the roof slab, or if you have pitched the roof, then up to the ridge level. Further, we need to have masonry walls straight and symmetrical in plan as far as possible. This is true for both the direction along x and along y. This symmetry always helps in achieving good seismic resistance. Then we can obviously have some limitation on thickness of the wall, which practically becomes equal to 200 millimeters. However, you can also have thinner walls. We will look into further details related to thin load bearing walls as we proceed through today's class. Further, we also need masonry to develop good bond between masonry unit and mortar. How do you achieve good bond? You use typical bonds such as English bond, Flemish bond, etc. I am not going into depth about those bonds because that is coverage for a separate course which you might be doing on design of masonry structures. So, but what you should ensure that the vertical joints in the masonry are not aligned. Vertical joints means head joint. Head joints should not be aligned in the same line. Then, if you have perpendicular walls like this, how do you get the bond between two perpendicular walls? So, one idea is that you first make a stepped joint by making the corners up to height of 600 millimeters. Up to this height of, let us say, 600 millimeters, you go on laying the brick in a stepped format in both the walls, and then you will the ball in between them. Or the other way out is that you can also provide toothed joint alternatively in both walls. As you can see here, we have provided toothed wall in one wall and then alternatively in the second wall, and so on. For each case, the lift is 450 millimeters. Okay, all these are available in clause 8.2 of IS 4326. 2013. Now, once we understand about ductile detailing of masonry walls, we also should understand that there will be openings in these walls. We need to open for doors and windows. So, the size of doors and windows should be preferably small and they should be located centrally. Now, the top of the openings should be preferably at the same level so that you can provide a continuous horizontal band. We have learnt about horizontal band earlier, which are usually provided at lintel and sill levels. At sill levels, we provide bands only under the windows, but the lintel level band, we hope that it should be continuous. So, that is why we want the top of the openings to be at the same level so that your lintel level band is continuous around the building. Then we have certain restrictions about different dimensions related to openings, which are available in table 4 and figure 7 of IS 4326. I have reproduced those tables and figures over here. This is table 4 from IS 4326 and this is figure number 7 from the same code. Now, I will go into one or two example related to dimensions. For example, in this case, any opening should have sufficient distance from the cross wall. This is a cross wall, that is, there is a perpendicular wall framing into this very wall. So from the face of the cross wall, the opening should be at a distance B5, which should be at least equal to 230 mm in case of building category C and 450 millimeters in case of building category D and E. So these are minimum values. Similarly, there are other geometrical restrictions for ductile detailing. We will look how to implement these restrictions as we go through the illustrative example problem. Now, once we understand the openings in walls, sometimes we may have to strengthen these openings. When your opening do not comply with the guidelines presented in table 4 and figure 7 of IS 4326, you may have to strengthen them. How do you strengthen them? You strengthen them by providing reinforced concrete or reinforcing the brickwork with 8 mm dia high strength steel bars. In case of jambs, steel may have to be increased in consultation with table 7 of IS 4326. Now, what is a jamb? Jamb is the band which is provided vertically on either side of the door. So, in case of jamb, you may have to increase the steel in consultation with table 7 of IS 4326. We will look into this table as we go through today's class. It gives you detail of minimum requirement of vertical steel for your masonry building. Then, if your window or ventilator is projecting outside, that is, it has a chhajja, then that projection has to be in either reinforced masonry or reinforced concrete. It cannot be an unreinforced masonry. Also, this has to be well anchored in the wall. Then, if you have a very tall opening, let us say from bottom to top of a story, so that your wall gets divided into two different portions, then in that case we need to reinforce both portions using 6 mm dia horizontal reinforcement at interval up to 450 millimeters, one on inner and one on outer face. We are providing horizontal reinforcement at interval of 450 millimeters, and there are two 6 mm dia bars, one on the inner face and other on the outer face of the wall, and these have to be properly tied to the vertical steel at jambs, corners or junction of the wall. Then we need to avoid arches spanning over opening. Let us say we have a window, and in that window we need to avoid arches, because arches introduce locations of weaknesses in walls. But if due to architectural provisions you cannot remove that arch, please provide a steel tie that will connect both sides of the wall across the window or door. Okay. So, there are other seismic strengthening measures which are also given in IS 4326 in form of table 5, figure 9 and figure 10, where figure 9 gives you the seismic strengthening measures for flat roof building and figure 10 gives it for pitched roof building, and table 5 gives you the strengthening measures which you need to incorporate for given building category and number of stories. Now, I suggest you have the code IS 4326 ready with you so that you can look into these. Now, at this point I would not like to discuss further into what size strengthening measures are to be adopted in building category B, as you can look into the code on your own. It is self-explanatory and it shall be more clear if we illustrate it through an example problem. In that, whatever is the required strengthening measures will be implemented. Okay, so once we have these strengthening measures, let us look into some of these measures. For example, we provide lintel band, roof band, gable band and plinth band. These are horizontal bands that are for providing integrity to the masonry building. So, these bands are made up of reinforced concrete typically or reinforced brickwork as well. If you are using reinforced concrete, you should be using M15 grade concrete or better. If you are working in a coastal area, then your concrete should be at least M20. So typically you shall use M20 grade conservatively everywhere for your lintel band and roof band, etc. If you are using reinforced brickwork, then the mortar should be not leaner than 1:3, and if you are implementing your solution in case of a coastal area, then the waterproofing admixture should be used in reinforced brickwork as well while preparing mortar. And we need to increase the thickness of joint to ensure that the minimum mortar cover of 10 mm around the steel bar. Now you might recall from our previous lecture 9.1 probably, that we have told that the cover around the reinforcement shall be at least 15 mm of clear cover. So though the code gives you contradictory minimum cover requirement for steel bars, we suggest that you should follow minimum clear cover to be as 15 millimeters in that case. Then for the section, the width will be the same as the thickness of the wall, and the minimum depth of these bands shall be 75 millimeters. Further, the steel reinforcement shall be given by table 6 of IS 4326, and as you can see that this applies to bands in reinforced concrete as well as reinforced brickwork, and in this case the longitudinal steel requirement is expressed in terms of number of bars and diameter of bars. So for a building category D, let us say if it has a span of 6 meters, we will need 2 numbers of 10 mm dia bars in our horizontal bands. So the reinforcement in these horizontal bands should be continuous at wall corners or junctions. For example, here there are 2 perpendicular walls framing into each other. So the longitudinal bar in this very band is continuing up to this point, and then we also have anchorage going on like this. Similarly, for this wall the longitudinal band reinforcement is up to the end, that is, it is continuous. Similarly, for a T-shaped wall as well, where you have a continuous wall and a cross wall is over there. So again you have to keep the steel in the horizontal band continuous. Apart from these, particularly in building category D and E, we also sometimes use double bars at corners and T-junctions at sill levels. These double bars are in the form of U stirrups of 8 mm dia till 900 mm length from inside corner in each wall. We need to use mortar of ratio 1:3 or richer, that is 1:3 is okay, 1:2.5 is perfectly fine, there is no problem with that. This is the ratio of cement is to sand. So a rich mortar is to be used, and minimum clear cover of 10 mm on all sides to minimize corrosion. But typically I would suggest that you should have a minimum clear cover of 15 mm, because the code also states it to be minimum 15 mm at one instance, and at other instances it tells you to have minimum of 10 mm. So it is conservatively it should be taken as 15 mm. Now once we have looked into horizontal reinforcement typically in form of horizontal bands, let us look into vertical reinforcement, which are usually placed at corners and junctions of the wall. So if your wall is less than 340 millimeters in thickness, then that is your brick wall has 1.5 brick in dimension, then we will use table 7 of IS 4326 to obtain the amount of vertical steel in masonry walls. Let us say we are constructing a building which has been classified as building category D. How do you classify these buildings? Based on seismic zone and importance factor. So let us say category D, let us say it is having 3 stories, then in case of 3 stories the top story should have vertical reinforcement bar of dia 10 mm and the middle story should have of 12 mm dia and the bottom story should have 12 mm dia bar. Okay, and this has to be provided in suitably created pockets. How do you create a pocket? You arrange your masonry unit in such a way that there is a pocket which runs all throughout the height of the building, and in the pocket you provide one reinforcement in each pocket, and that reinforcement has to be embedded or covered by M20 grade concrete or 1:3 mortar or a higher grade concrete or mortar, and this reinforcement has to be anchored properly in plinth or roof slab. How do you anchor it properly? You end up providing sufficient development length in tension, and this has to pass through all the lintel and floor level bands in all stories. So, this very pocket is throughout the height of the building. I have shown some of the schematic diagram for these pockets over here, which has been obtained from figure 12 of IS 4326. You can look for more details, a clear picture into the code IS 4326. Then I talked about thin load bearing walls earlier, that though we say that the walls have to be minimum 200 millimeters thick, sometimes due to architectural concerns you may not build a wall which is more than or equal to 200 millimeters. In that case, we need to provide RC framing columns and collar beams. So, what are these columns and beams that we need to provide? We need to provide them at very smaller spacing. These columns have to be spaced at not more than 1.5 meters, and the maximum horizontal length of wall between cross wall can be only up to 7 meters. It cannot be more than that, but if you use a wall which is thicker at least 200 millimeters, then you can have a larger length of the wall as well. Then we will be providing horizontal bands at lintel and roof levels of all floors in such cases, and there are some construction sequence over here. First of all, we will build the wall up to 4 to 6 courses height, leaving toothed gap, and the tooth projection is roughly 40 millimeters for column. Then we will pour M20 grade concrete or a higher grade concrete to fill the columns while holding column steel accurately in position. Now, this very construction sequence is similar to what we do in case of a confined masonry construction. Slightly different, I would say. Why? Because this is only building a wall up to 4 to 6 courses height. What is course height? Every brick you lay is one course. So, if you are laying 6 bricks on top of each other, then you have laid 6 courses. So, but in confined masonry construction, you end up building the wall to the story height and then you pour concrete to build the tie columns. So, that is slight difference in the construction sequence. Then in this case, we should also limit such construction to 2 stories with maximum story height of 3 meters. Sometimes we also use reinforced masonry. How do we use reinforced masonry? For that, we need to use hollow block masonry blocks. So, hollow block masonry is a masonry block in which we have an orifice, that is the unit is hollow. So, that allows us to provide vertical steel throughout the building height or the wall height. But how do you provide the horizontal steel if you are building a reinforced masonry wall? Horizontal steel is provided by introducing a U block for horizontal bands. So, you provide a U block as shown over here. In that you use the longitudinal steel. How much longitudinal steel? 25% more than the longitudinal steel requirement posed by table 6 of IS 4326, and you have to use minimum of 4 bars. You cannot get away with 2 bars of higher diameter. No, that is not possible. And we have already seen table 6. I will show you once again. So, this is the table 6 which gives you the recommended longitudinal steel in reinforced concrete bands which depend on building category wall, and in this case it gives us in terms of number of bars and in this case it gives us the required steel in terms of number of bars and diameter of bars. So in this case we shall be using 25% more steel than the table 6 guidelines, and we shall also use minimum of 4 bars. Then in this case we shall also use 6 mm dia stirrups to hold those bars in place, and then this U block shall be continuous at wall corners or junctions. So this is shown in figure 11. I have shown it over here, the continuity of that. As you can see, horizontal bands are usually built continuous, and the reinforcement of the horizontal band is also continuous. Now when it comes to vertical steel, then we provide 1 bar in each cavity. Now since we are using hollow block masonry, we have the holes ready with us. So in each cavity or hole we provide 1 bar, and then the cavity has to be filled with either micro concrete or cement sand mortar. The micro concrete will have the mixed proportion of 1:2:3, and cement to sand ratio shall be 1:3, and these micro concrete or mortar is rodded for compaction. Then since you are providing these vertical steel till throughout the building height, you will need to splice it somewhere. So for splicing you end up providing development length in tension for lap splice. Also you use binding wires throughout the splicing length as shown over here. You can see these binding wires shown over here. Here in table 7 you see the vertical steel reinforcement requirement in masonry walls with rectangular masonry units. So based on number of stories, for each story for the building category we get what is the diameter of high strength steel bar that can be used or should be used in that case. So summarizing, we have looked into various ductile detailing provisions related to geometry, aspect ratio of walls and reinforcement detailing. In the upcoming classes we will look into illustrative example which will demonstrate how do you achieve the seismic design of masonry walls. Thank you.